This is an extra video in our Excel example series. It provides a more detailed explanation of Facet Space and how it can help you design Excel spreadsheets for users to explore complex data. If you've not yet looked at example 3, you should look at that video before coming here. This video is slightly different from the previous 3. I'm going to provide some background that helps to understand example number 3. We don't have a specific spreadsheet for this video. The one shown in example 3 illustrates all the points I'm going to make. I realise that this is a chunk of theory and won't be to everybody's taste, but I hope it will deliver some invaluable insights that dramatically improve the spreadsheets you create. In this video, we're going to be exploring facet space, that is, thinking about the data in terms of the values of its facets. I've found that, particularly with complex data sets, this approach helps clarify the data architecture. In addition, it often uncovers views of the data that I had not originally considered, but which users find invaluable. What do I mean by the term facet space? In any real set of data, the underlying entities have a number of attributes, properties, or categories they fit in. I'm going to refer to all these as facets of the data. Each facet has a restricted set of values that it can take. If we list the valid values of one facet up the page and another across it, we can define a plane that covers all the potential values of these two facets. Any one data entity has a position in this space determined by its values of those facets. Every other entity also occupies a location in the same space. Restricting ourselves to just two facets doesn't get us very far. So let's add one more, and now the data entities have a position in 3 dimensions. Of course, any real set of data will have more than 3 facets, but it is quite hard to show more than 3 dimensions on this display, so I'll just pretend that 3 is enough. We're really talking about locations in an n-dimensional space where n is the number of facets. The obvious way to select a set of data to show to the user is to take a slice. The user has to specify the level to pick the entities from. Or we can take a slice in a different direction. For any of these directions, we can either select just a single plane, or we can squash the entities together and show a summary. As we saw in example 3, the typical data exploration application has 3 parts: the data, some way of modifying it, and a set of views, each one of which displays some kind of slice through the data. In the example 3 video, we saw a typical view tab. As I said, this usually has 3 main elements: the control, which defines what we want to see, the primary dimension that provides a list of values for one particular facet, and the slice, which shows how these values interact with another facet. There should also be some additional values for the primary items, and a list of the values of the secondary facet for the slice to make sense. To define all the views you ought to implement, the best way is to list all the facets of the data down and across the page. Here we have 5. Each intersection is a candidate for creating a view. If we look at this cell, for example, the primary dimension is based on facet 4 and the secondary one is facet 2. Sometimes there's also a good reason for providing a view that swaps these two around. That is, one that occupies this cell. Often, having both views would be redundant, but you should always consider it. In fact, you should carefully consider creating a view for every cell here. This will usually reveal views that you had not thought of, and often they will be exactly the ones that users find the most useful. When we look at the view indicated by the yellow square, the three facets that are not selected would each normally show up as a user pickable element. The user would want to control which values of facet 1 should be shown in this view, for example. Do we want to squash facet 1 values together or only select items that have a particular value? These considerations also occur for facet 3 and 4. In this example, the primary dimension is the project, the secondary is the department. The control selects the time period, either a single year or squashing all the years together. The customer is an extra facet. We could have this selected in the control area. However, because each project has a single customer, this has been viewed as an attribute of the project rather than a selection from the pick list. If you want to test your understanding of these principles, have a look at the other views in example number 3. And that's all I'm going to cover here. This has been a bit abstract, but I hope you've picked up something useful. If you found this at all valuable, please leave a comment. Thanks for watching to the end.